Lesson 4.1, Solving Equations by Factoring. So in our previous lessons, lesson 3.1, where we learned how to factor when a is not equal to 1, and lesson 3.2, when we learned how to factor difference of squares. We also had 3.3, where we learned how to factor completely. All of those skills will be involved in lesson 4.1, where we're asked to solve the quadratic by factoring. So what does that mean to solve a quadratic? In order to solve a quadratic, basically that's saying, when is the function equal to 0? If you look at the notes that was posted in your folder for lesson 4, there were some notes on a diagram. And on that diagram, I showed you where your solutions would be found. So later on in the next section, we will be solving by graphing. But for this particular section, we're going to be solving by factoring. So again, if you look at the diagram, you were able to see where your solutions are located. Your solutions are located on the x-axis. They are your x-intercepts. Other words for x-intercepts would be roots, zeros, and your solution. So when I ask you guys what is the solution to the quadratic, I am asking you what are the x-intercepts. And because we know that the x-intercept is where y equals 0, this is why we set our function to equal 0 when solving quadratics. So the first thing you must do is make sure that your quadratic is equaling 0. If it does not equal 0, you must rewrite your equation so that it does equal to 0. The steps for factoring will be, first, you're going to factor completely if it is not factored. So which means if you're given a trinomial, you must first factor that trinomial. And then your factors will be set equal to 0 and you would be solving for x. So let's take a look at the first problem here where we have x times x minus 2 is equal to 0. We're going to factor this completely and we're going to solve. So the first thing I would need to do is set anything that has an x value to equal 0, because we know that anything that has an x value is going to be a solution. So right now, I am going to set this x to equal 0, and I'm also going to set this factor to equal 0. I am now going to solve. Well, right now, this is telling me that one of my solutions will be 0 because it's saying that x is equal to 0. The other one I have to solve for x. In this case, I'm going to add 2 on both sides, so x is equal to 2. So my two solutions, my two roots, my two zeros would be x is equal to 0 and x is equal to 2. Now, what exactly does that mean? That means if I were to take this value and plug it in, it would make my entire function equal 0. So if I were to take 0 and plug it in here and here, where x is 0, and solve, or simplify rather, it will equal 0. So we know that 0 times, this would be a negative 2. So 0 times negative 2 does equal 0. Also, if I were to put a positive 2 in for x, 2 minus 2 is 0, and 0 times 2 is 0. So that means that either a 0 or a 2 would be the value of x that would make that equation equal 0. So again, these two are my solutions. According to the diagram, if I were to solve this by graphing, which we will do on the next section, you will see my parabola crossing through the x-axis at 0 and a positive 2. So right now we are learning how to solve by factoring, but later on we will look at when we're solving by graphing, you will see that these x values are your x-intercepts on your graph. Let's take a look at number 2. Once again, my quadratic has already been factored. We call this factored form. So I'm going to set each factor to equal 0. And then I'm going to solve. Adding 3 on both sides. X is equal to 3. That is one solution, or one zero. We call it a 0. Subtracting 4 on both sides. The other 0 solution, roots, x-intercept, all of those words mean the same, is negative 4. So once again, I have two solutions for this. That means if I were to plug in a 3 here and solve, it would equal 0. If I were to plug in a -4 here and solve, it would equal 0. So this is where my function equals 0. This is why we set our function, which is y, to equal 0. We want to know what would the x values be that would make the entire function equal 0. And in this case, it would be a 3 and a -4. Solving this one, already in factored form, I'm going to set it to equal 0. 2n minus 4 equals 0. 3n plus 5 equals 0. I am now going to solve this equation. 2n, adding 4 on both sides, equals 4, dividing by 2, n is equal to 2. Subtracting 5 on both sides, 3n is equal to -5, dividing by 3, n is equal to 5 over 3. So again, this particular quadratic has two solutions. If I were graphing, it would cross the x-axis at a +2 and a -5 over 3. So these are my roots, my zeros, my solutions, my x-intercepts. Looking at number 4, notice that my function is not in factored form. Again, this is factored form, which means I have to factor this trinomial to get it into factored form. So as we've learned in the previous lesson, lesson 3.1, we're going to factor this trinomial using the trick when a is not 1. So I am multiplying a times c, and that would give me a -56. I need all of my factors of a -56. Hopefully you guys will get pretty good at this. For the sake of keeping the video short, I will tell you what those factors are. -8 and a +7. On our previous lesson, we understand that we are going to put 2x here, -8 and a +7. I am going to simplify divisible by 2. 0 is equal to x minus 4 and 2x plus 7. So now I have just put my quadratic in factored form. From here, I'm going to solve for my solutions. Again, my factors are set equal to 0. So I'm going to set each factor to equal 0 and solve. X is equal to 4. Subtracting 7 on both sides. 2x is equal to -7. X is equal to a -7 over 2. So again, I have two solutions, one of them being 4 and the other one -7 over 2. Once again, this is where my parabola, the graph for the quadratic function, would cross the x-axis at two places, a +4 and a -7 over 2. For number 5, I'm looking at my quadratic and I'm noticing that it does not equal 0. So therefore, I must make it equal 0. What I can do is, normally I'd prefer to have, especially when you're factoring, your a value to be a positive number, positive leading coefficient. So since 1 is already positive as my a value, I am going to move this side over here. So that means I'm going to subtract a 24 and add a 5a. And I'm going to place those values on the left-hand side. From there, I'm going to write it in standard form. So that would be a squared plus 5a minus 24 now equals 0. From there, I'm going to factor. I'm going to look at the c value because a is 1. I need a -24. For the sake of saving time, I'll tell you what those factors are. They are 8 and -3. I'm going to set up my parentheses for my factors. Plus 8 minus 3 equals 0. Now that I have it in factored form, I'm going to set each factor to equal 0. A plus 8 is equal to 0, and a minus 3 is equal to 0. Solving for a, one of my solutions is a -8. The other is a +3. For number 6, once again, my quadratic, it does not equal 0. So in order to solve any quadratic, it must equal 0. So the first thing I'm going to do is I'm going to set this to equal 0. Wanting a leading coefficient to be positive, I am now going to move this on this side. Writing this side in standard form, that's a positive 3x squared minus 19x plus 6 is equal to 0. Because a is not 1, I'm going to use my trick. I need a positive 18, but negative 19 when I'm adding together, so that means that both numbers would have to be negative. Setting up my parentheses, 3x minus 1 minus 18 equals 0. Simplifying, divisible by 3. 3x minus 1. This one would be x minus 6 is equal to 0. From there, I'm going to set each factor to equal 0. Adding 1 on both sides and dividing by 3. This would be a 1/3. X is equal to 6. So my two solutions are 1/3 and x is equal to 6. Here I have a word problem. The area of a rectangular room is given by the equation. So here is my quadratic equation that represents the area of the rectangular room, where W is the width of the room. We're going to find the width. Okay? So if this is my area and they're asking me to find the width, meaning a dimension, so then I need to come up with the two things that were multiplied together to give me the area. So those are my dimensions. So right now my area is being expressed as a quadratic, but it does not equal 0. So in order for me to work this problem, I first must, I'm going to rewrite it the way it is, make it equal 0. In order for me to make that to equal 0, I'm going to subtract 18 on both sides. W squared minus 7W, minus 18 equals 0. Now I can factor this trinomial. Factoring the trinomial, I need a negative 18. I need a negative 9 and a positive 2 to give me that negative 7 in the middle. So W minus 9 and W plus 2 equals 0. I'm going to set each factor to equal 0. W is 9 and W is negative 2. Now for this particular problem, this is a word problem, so we have to think realistically. Realistically, we have to ask ourselves, which answer will be correct? Because I can't have two different widths. So because we're talking about dimensions, we're talking about measurement. If these two numbers represent my width, only one can be correct. In this case, it is the 9 because it is a positive number. We cannot have negative measurement. We can't have negative inches or negative feet. So the only correct answer for this particular word problem would be 9 because it is a positive value. And measurement is in a positive value, not in negative. Okay. We're going to look at some more problems. Looking at number 8. I notice here that my quadratic does not equal 0. So I'm going to rewrite that so that it does equal 0. Here I already have my leading coefficient is 1. So it only makes sense to bring this side over here with the s squared. So that means I'm going to subtract 18s and add 81s for those to zero out. When doing that, I'll now have a s squared minus 18s plus 81 now equals 0. I am going to factor. I need a positive 81, negative 18. So that means we have to have a negative 9 and a negative 9. Putting a negative 9 and a negative 9 here. Setting them both to equal 0. If you notice here for this particular problem, the factors are exactly the same. So there's no need for me to solve both of these because I will get the same answer. So I'm going to solve one of them, and s is equal to 9. That means I only have one solution for this quadratic. When we take a look at graphs, that means that that quadratic, that parabola, will only cross the x-axis one time, and it will cross at a positive 9. So again, this quadratic only has one solution. For number 9, we're going to look at does not equal 0. So I'm going to bring the 25, subtracting it off, and bring it on the other side. So that's 16x squared minus 25 now equals 0. So with that equaling 0, I'm going to look and say, well, that looks familiar. That's difference of squares. My a value is a perfect square. My c value is a perfect square. So I'm going to take the square root of a and c. And also there's subtraction in the middle. Very important. So the square root of 16 is 4. So that means I'll have a 4x and a 4x. The square root of 25 is 5. And in order for the middle term to cancel out, one has to be positive and the other has to be negative. Again, this was difference of squares. Now that I have it in factor form, set equal to 0, I'm going to set each factor to equal 0. Solving this, 4x is equal to negative 5, so x is equal to a negative 5 over 4. There is one solution. 4x is equal to positive 5, so x is equal to 5 over 4. Here is the other solution. So again, this quadratic has two solutions, two roots, two x-intercepts. Those two solutions would be a negative 5 over 4, as well as a positive 5 over 4. I am looking at number 10. Number 10 does not equal 0. So I am going to, since this is my leading coefficient already positive, I'm going to bring the right side to the left side by subtracting 2b and subtracting 3. Now I have an 8b squared minus 2b minus 3 now equals 0. Factoring when a is not 1, I need a negative 24. I'll be using a negative 6 and a 4, because that will give me my negative 2. Setting up my parentheses for my factors, 8b and 8b minus 6 plus 4 is equal to 0. Simplifying, divisible by 2, divisible by 4. 4b minus 3 is one factor. The other would be 2b plus 1 is the other factor. Again, I'm looking for my solution, so I'm setting them both to equal 0 to solve. Adding 3 on both sides, dividing by 4. 3 over 4 would be one of my solutions. Subtracting 1 on both sides, dividing by 2. Negative 1/2 would be my other solution. So these two are my two solutions. This is where, once again, if I were to plug these values in for b, it would make the entire quadratic equal 0. So therefore, that tells me these are my x-intercepts. For this particular problem, it is already equaling 0, as you notice here. It's just the zeros in the front instead of the back. If you don't like it, you can always put it back here. This is my leading coefficient because of the x squared. I'm also looking at 24 and 8, and I'm also looking at x squared and 8. So this now tells me I need to factor completely. I have a GCF. That GCF would be 8x. So I am pulling out an 8x. Again, this was the lesson that was taught in 3.3, factoring completely. So now that I am factoring out an 8x, I'm going to write the resulting polynomial. That's a 3x minus 1 equals 0. Again, what's important about when factoring completely, any term that has an x is set equal to 0. So this particular term has an x, so I'm going to set this one to equal 0 because I can solve x equals 0 for that particular term. I'm also going to set this one to equal 0. So that's adding 1 on both sides. So x is equal to 1/3. So again, this has two solutions. Looking at the last two, it does not equal 0. This is my leading coefficient. I want it to be positive. Right now it's negative. So I am going to move it on this side. I'm also going to move the 6n to the other side so that this whole side again will equal 0. So I'm going to do an add 20n squared and a minus 6n. And I'm going to move it on the other side. My leading coefficient being 20n squared. Then my middle term is 6n. This will remain a -2 because it did not move. It still remained on the left side of the equal sign. So now I'm looking at my trinomial. I'm looking at a 20, a 6, and a 2. I know that that does have a GCF. GCF would be 2. I am pulling out a 2. So that's 10n squared minus 3n minus 1 is equaling to 0. I am now going to factor. A is not 1, so I need a -10, but I need a -3. So I'm looking at a -5 and a +2. Still with my 2 on the outside. I am now setting up my factors. That's going to be a 10n minus 5 plus 2 equals 0. Simplifying, divisible by 5, divisible by 2. Now I have 2 still on the outside. 2n minus 1, 5n plus 1 equals 0. For this particular problem, remember the only thing that has an n will get set equal to 0. Anything that has a variable, in this case, it's not an x, it's an n, gets set equal to 0. This term, this GCF, does not have a variable, so therefore it will not be set equal to 0. But these two will. 2n minus 1 is equal to 0. 5n plus 1 is equal to 0. Final answer here, n is equal to 1/2. There's one solution. N is equal to -1/5. There is the other solution. Once again, because this one did not have a variable like 11, this is not set equal to 0. But this one is, because if we write 2 equals 0, that doesn't make any sense. However, we can do 8x equals 0. We can solve for x. So only when it has a variable does it get set equal to 0. Our last problem here, it is set equal to 0. Leading coefficient is 12. Not difference of squares, because 12 and 3 are not, neither one are not perfect squares. But I do have a GCF of 3. So we're going to pull out that 3 for r squared minus 1 is equal to 0. I do notice now I do have difference of squares. My difference of squares for square root of 4 is 2 and the square root of 1 is 1 with subtraction in the middle term missing. 3 on the outside, factoring my difference of square. 2r plus 1, 2r minus 1. Again, the only thing that gets set equal to 0 will be those terms or those factors that have a variable. So 2r plus 1 equals 0. 2r minus 1 equals 0. Subtracting 1 on both sides, that's 2r is equal to -1, so r is -1/2. There is one solution. Adding 1 on both sides, 2r is equal to 1. R is equal to a +1/2. So these are my two solutions. So once again, this is solving by factoring. Some of the key things you need to know is that your quadratic must equal 0. When you are solving, look for your GCF if there is one, meaning factor completely. And then once you have factored, make sure that each factor that has a variable is set equal to 0, and then solve.